All right, so today we are changing shapes and we are going to go into pyramids and cones. So everything before had two bases: prism, two base; cylinder, two bases. Now pyramids and cones, as you can see there, only have one base. So a pyramid has one base, okay, fine. And then we're going to introduce this new word which is called slant height. Slant height right here, and you'll see what the slant height is basically the height of the triangle that's on the side, and it's kind of like slanted. And the letter they use for the slant height is a cursive L. A cursive L. So what slant height is the height of the triangle on the side. So the height of the triangle that's like on the side. But the picture is really what shows it the best, right? That picture shows that slanted height or the slant height. So here's our formula. Now we know what lateral area is. Lateral area is the area of the sides. And we're going to do it real similar to before, where we have perimeter of base. But now instead of timesing by the regular height, we're going to times by the slant height, and then divide by 2. And again, you don't have to memorize the formulas. And the divide by 2 makes sense, right? Because we have a triangle. We know in triangles we divide by 2. Perimeter of base times slant height divided by 2. When we do the total area, we'll take what we got for the lateral area and we'll add on the area of the base. But the nice thing is, because we only have one base, we don't have to do it 2 times. So we don't have to do that multiply by 2. We just add on the area of the base 1 time. So here's our first pyramid, and you'll notice that the pyramids that we do are pretty much going to have square bases. Every once in a while we'd have a rectangle base, but most of the time we've got a square base. So 7 plus 7 plus 7 plus 7 is how I got 28 inches for the perimeter. The slant height is 9. Those both have plane units. And then for the lateral area, if I follow my formula, slant height times perimeter divided by 2. And I would do that on my calculator. It turns out to be 126 inches squared. Slant height times perimeter divided by 2. So the area of the base is just the area of that square. Area is base times height, so 49 comes from 7 times 7, and then I'm going to add the 126 plus the 49, 175 inches squared. Lateral area plus area base. That's it. So we'll try it again. Here now my area of my base or my perimeter is going to be the perimeter of this square. 6 plus 6 plus 6 plus 6 is 24 feet. But if you look closely, you'll see that they didn't give us the slant height, but they gave us what we call the regular height. And if we look real closely in here, you'll see a right triangle. And we're going to use our old friend Pythagorean theorem to help us find that slant height. So the regular height is 4, that goes there. And because this was 6, right, and this kind of went from the middle to the edge, that's 3. You might know by heart what the slant height is. We've done this problem so many times, right? 9 plus 16 is 25. Square root of 25 is 5 feet for the slant height. So a little extra work for that problem, right, to find the slant height using a squared plus b squared equals c squared. Lateral area, following my formulas, perimeter base times slant height divided by 2. So 24 times 5 divided by 2, that's 60 feet squared. Area of the base is going to be 6 times 6, or 36 feet squared. I got that by 6 times 6. And then for the total area, I'm going to add up the lateral area plus the area of the base, 96 feet squared. And that's it. If I do some of these problems where you have to go backwards, again, I'm just going to write out my formula. Lateral area equals perimeter times slant height divided by 2, just kind of abbreviating everything. Plugging in what I know, not with units, just the numbers. So 50 equals 10 times the slant height divided by 2. or I know that 10 divided by 2 is 5, and what times 5 gives me 50 is 10 centimeters for the slant height. Here, total area, we know, is lateral area plus the area of the base, just one time. The lateral area is 75. The area of the base is 15, so the total area, if I add those up, is 90 centimeters squared. So again, for those problems, I'm really just writing the formula out, plugging in what I know, and then working out what's missing. Oh, I have one more. So let's see, lateral area is slant height times perimeter times slant height divided by 2. So 30 equals P times 6 divided by 2. Well, 6 divided by 2 is 3, and the number that times is by 3 to give me 30 is going to be 10, and so it's centimeters, perimeter plane units. Perfect. So that's pyramids. And now we're going to do the same formulas, but with a cone. So a cone is what I call a circle pyramid. A cone has a vertex, which is right at the top, right? It's got also a slant height, which is like this slanted height. So I'll just say that the slant height is here. That's also going to be called L. Of course, we've got the radius of the circle. And then this segment here is going to be what I call the height, or just H for the height. And you'll notice that those three make a right triangle. So we'll use that right triangle a little bit later. So the slant height is L, and we'll just leave it at that. We had it on the picture. We know from doing it about 1,000,000 times that pi times diameter is circumference, and area is pi times r, or pi r squared. So quick review there. So our formula here is going to look really familiar. Instead of perimeter times slant height divided by 2, it's going to be circumference times slant height divided by 2. And the circumference is essentially the perimeter of the circle. So lateral area, circumference times slant height divided by 2. Total area is going to be lateral area plus the area of the base. Or, because our base is a circle, lateral area plus pi r squared, because our base is always a circle. Okay. All right, so now we've got two cones. This first one's kind of an upside down cone. I always ask you for the radius and the diameter. So it looks like the radius here would be 4 inches, diameter 8 inches. Circumference we know is pi times diameter, so just 8 pi. And I could just read the slant height right off the picture is 6. Lateral area is circumference times slant height divided by 2, which is going to be 24 pi, area square, inches squared. Area of the base is a circle, oops, it's pi times 4 times 4. Sorry, pi times 4 times 4, or 16 pi inches squared. And then I'm just going to add those two up, and they add up to 40 pi inches squared. And again, how I got that was just adding the 24 pi plus the 16 pi. So the same process that we did with the pyramid, the only difference was the base is a circle. That's the exact. If I do the approximate, so here, what do I have? I've got radius, it looks like 12 feet. So diameter is 24 feet. If I bounce down here to circumference, 3.14 times 24 is 75.36, right? Feet squared. Now the slant height, you'll see I don't know it. But you notice in here that the radius and the height and the slant height all make a right triangle. And you might even be able to tell the slant height by heart once you see the Pythagorean theorem. 5 squared plus 12 squared equals L squared. So we've done this a whole bunch of times, and you might remember when I square root that, 13 is going to equal the slant height. So 13 feet. So what I'm going to do now, I'll probably just type it on my calculator, right? 75.36 times 13 divided by 2. Circumference times slant height divided by 2 gives me, looks like 439 or 489. Hang on, I gotta see here. Yeah, 489.84. 489.84 feet squared. Approximate area of the base, so we know it's pi r squared, so 3.14 times 12 times 12 is 452.16 feet squared. And I'm just going to add those two up, and that turns out to be 942 feet squared. All right, the last ones here are going backwards, and again, I'm going to write out the formula. Lateral area equals circumference times slant height divided by 2. So 150 pi is equal to 15 pi times slant height divided by 2. Now, usually I would divide by 2 first, but I think with this one, 15 is an odd number, so I'm going to divide both sides by 15 pi. And that's going to give me 10 is equal to slant height divided by 2. So the slant height has to be 20 centimeters. 2 more. Total area we know is lateral area plus area of the base. So I got a 70 pi and a 20 pi. So if I add those up, don't I just get 90 pi centimeters squared? 90 pi. And then the very last one, find the circumference. So lateral area is 25 pi, circumference I don't know, times 10 for the slant height divided by 2. So 25 pi, 10 divided by 2 is 5, right? So if I divide both sides by 5, the circumference here is 5 pi centimeters, cm, centimeters. So again, those are the ones where you're going backwards. Just to review one more time, pyramids and cones, one base. We follow our formulas, which are essentially perimeter times slant height divided by 2. And to find the total area, we add on the area of the base one time.